Okay, so let's look at number 10. For number 10, there's one thing that should have been given to you that was not. So I'm just going to add a given to this. Given that line segment AE is parallel to line segment BD. Okay. It says some bikes use a triangular framework, use deductive reasoning to prove that triangle ACE is similar to triangle BCD. Well, key here is it says deductive reasoning, right? So deductive reasoning means facts, and here in geometry, one of the ways we've been using deductive reasoning is through a two-column proof. So the fact that it says deductive reasoning should have helped you to know that a two-column proof would be needed. So then we're going to have a statement and a reason. Okay. And then you're going to have to prove something. And so it says that prove that triangle ACE is similar to triangle BCD. So I just translated the words into the symbols that I need to use. This is what I should end up with because that is what I'm trying to prove. Trying to prove that. Okay. So I look at my pictures and I also consider what ways can I prove that a triangle is similar to another triangle? So I kind of just brainstorm, and this is off to the side. It's not over here. It's just brainstorming. I know that there is side, side, side. There's side, angle, side, and there's angle, angle. Those are the three ways I can prove a similar triangle. So I'm going to look at my picture, and I'm going to look at my givens, and I'm not given any sides or any angles, so that doesn't help me. So I look at my picture, and let me look at my sides here. I could make a proportion between 6 and 14 here, which would mean this 20 here would have to be proportional to the length of CE. And I can see that I can find no amount for CE. I can't find an amount for DE to add in. I cannot possibly do sides because I definitely don't have 3 sides. I don't even have 2. I have 1 here, but I don't have the full second one. So I know I can't use these 2. It's not possible. So I know I'm going to have to be using angle, angle. So I have to try to find the angles that are similar. So I'm going to go ahead and look at some of my notes to help me out here and see if I can find some angles that would help me. So if I look right here, I'm going to notice that I have this angle here and that it is a shared angle. So the terminology for that is reflexive angles. You can see that that is what we need to do. So I'm going to say that angle, and I'm going to start with the big amount. So ACE is similar, or is equal to, is equal to angle BCD. And the reason for that is that they are reflexive angles. Okay, so then I need to find another angle that's similar. So I'm going to try to find one that I need to be similar. Well, I would need, let's say, angle A to be similar to angle B, or I would need angle E to be similar to angle D. Okay, but I'm going to go with A and B because that's just the ones I chose. So I'm going to look at some information I have over here to see what kind of angles that would be, like that. And I can see that this is on the top of that line and this one's on the top of that line, so they are corresponding angles. But I can see here, in order to have corresponding angles, these have to be parallel lines. Okay, so I have to see, are these 2 lines here parallel? So I look up to my given, and sure enough, they are. So line segment AE is parallel to line segment BD, and that is a given. Okay. So then I can say that because these are parallel, that these 2 angles are corresponding. So I could say that angle is equal to angle DBC because they are corresponding angles. So now I have two angles that are similar. So I can now say that triangle ACE is similar to triangle BCD, and the reason for that is angle. All right, so there is a part B to this, and that says what is the length of DE? Okay, so DE is this portion right here. It wants to know how long that is. Well, since they are similar, I can use a proportional relationship to figure that out. So I'm going to go ahead and put an X right here because that's what I don't know. Okay, so I'm going to do small to big for my ratio proportions, and I can see here that 6 goes with 14. So 6 to 14, and I'm doing small to big to keep it straight, is equal to small is 20. Uh-oh, big is not X. Do you see that that's only this portion? Big is this entire line right here, that entire thing. So I have to have a way to represent that. So I'm going to say that it is 20 plus X. Do you see what I just did? I need this entire amount, not just this amount. So it's not just X, it's 20 plus X. So then I'm going to use some cross multiplication here to solve this. So I'm going to do 6 times 20 plus X. And then I'm going to do 14 times 20. And it's okay if you don't want to do that in your head. Go ahead and grab a calculator. 280. Okay. So then I can see here, in order to solve for X, I would have to distribute the 6. So 6 times 20 is 120. 6 times X, remember that's 1X, so that's 6 times 1X is 6X equals 280. And then I'm going to have to subtract 120 from both sides. And I'm going to have 6X equals 160. Divide both sides by 6. And then I go ahead and do 160 divided by 6. And I'm going to get 26. And then I get a big old long decimal. Okay. So I'm going to turn that decimal into a fraction. So I'm going to minus the 26 off of there. And I'm just going to have a repeating 6. Then I'm going to hit math, enter, and that turns it into 2/3. So 26 and 2/3, what? What are we talking about? Well, you can see here that all of these were inches, so this one is also inches.